In this video, we're going to talk about factoring by grouping. Previously, we talked about factoring using the greatest common factor, which we're going to need in factoring by grouping. So let's go ahead and review some factoring out the greatest common factor. To find the greatest common factor, we need to look at each of our terms and determine what numerical value goes into each of these evenly. So what's the biggest number that all of these can be evenly divided by? Now, all of them are divisible by 2 because they're all even. These two are divisible by 6, but 2 is actually going to be the biggest number that goes into all of those evenly. We also then have to look at the variable component, and all of these have at least x to what degree? This is x to the 5th, x cubed, x squared. All of them contain at least x squared. So 2x squared should be our greatest common factor. So remember, factoring out the greatest common factor is essentially undoing the distributive property. So once I pull out 2x squared, what am I left with? 2 times 9 gives me 18, and then x squared times x to the 3rd gives me x to the 5th, because when you multiply powers at the same base, you add the exponent. What do I have to multiply 2 by to get 12? I have to multiply by a 6, and then x squared times what gives me x to the 3rd? Well, that's going to be x to the 1st. 2 times what gives me negative 32? That's going to be negative 16. Now, I already have x squared, so I don't need any more x's. So this should be my factored polynomial. Now, you can always double check that you factored out the entire GCF by looking at the terms inside your parentheses. If they have anything else in common, then that means that you actually missed something when looking for the greatest common factor. But it doesn't look like these have anything in common, so that is the completely factored form. Now, when factoring by grouping, we're essentially doing the same thing, except we're going to be looking at factoring something like this. We have a binomial times a binomial. Remember, when you multiplied something like this, we used the distributive property, and we'd get like x cubed plus 3x squared, and then a minus x and a minus 3. None of these can combine, and we'd be left with this cubic polynomial. This process was multiplying using the distributive property, going this way. Now, factoring by grouping allows us to take this polynomial and go back into our factored form of two binomials. And that's what we're going to look at right now. So let's go ahead and jump into this first example. So we want to factor this by grouping. So in order to factor by grouping, we want to have a polynomial that has 4 terms. You can actually do this with any polynomial that has an even number of terms, but for our purposes, we're going to focus on 4-term polynomials. And not every 4-term polynomial is able to be factored by grouping, but it should be the first method that you try after factoring out the greatest common factor if possible. So let's go ahead and jump into factoring by grouping. So the first thing we want to do is we're going to split this polynomial into 2 different parts. So we're going to split it right down the middle, and we're going to focus on factoring out the common factor for each half of these. So in looking at the first half, what is it that these 2 terms have in common? They're both divisible by 4, and they both have at least n to the 2nd power. And now we're going to undo the distributive property and factor out the greatest common factor. So 4 times what gives me 4? Well, that's just going to be a 1. And then n squared times what gives me n to the 3rd, and that's just going to be n. So really, we're going to multiply 4n squared just by n to get 4n to the 3rd. You could think of this as a 1n squared, but we don't need to put that coefficient of 1. What do I have to multiply 4 by to get 8? Well, I can multiply by a positive 2. And if I have n squared here and n squared here, I already have all of my n's accounted for. So that's going to be that first factor. Now, for the second one, you're going to look at these groups, and you need to pay attention to the leading coefficient. The leading coefficient is going to determine the sign of whatever it is that we factor out. So because this leading coefficient is negative, we're going to factor out a negative number. So what do negative 5n and negative 10 have in common? So negative 5 and negative 10 are both divisible by 5. So we're going to pull out a 5. And this has an n, but this doesn't. So we can't actually take out an n because this doesn't have an n in common. So negative 5 is actually going to be our greatest common factor of those 2 terms. And what do we have to multiply by to get this? So negative 5 times a positive 1 will give me negative 5, and negative 5 times n would give me the n. So it's actually going to be a positive 1 n, right? And we, again, don't need to write the coefficient there. Negative 5 times what gives me negative 10? Well, I'm going to multiply by a positive 2, because a negative times a positive gives me a negative. Now, something to pay attention to in this is what we have here, right? We notice that this n plus 2 is the same as that n plus 2. And that's actually pretty important, and that's a key thing that you want to look for when solving or factoring by grouping. If you factored by grouping correctly, you should have your binomial group be the same. So this should be the same as this, which means that's actually going to be the first group, the first factor of our two binomial products. So n plus 2 and n plus 2 is our first factor because it's what they have in common. So we're able to factor that out. Now, what's the other factor going to look like? The other factor actually comes from what's out in front. Because remember, this 4n squared and this negative 5 are technically being distributed into this n plus 2. So each of those terms is multiplying n plus 2, and then we're distributing it through. So the other binomial is just what's on the outside. We just put them together and make our second binomial. And you could always double check this by distributing through, right? We could do 4n squared times n, 4n squared times 2, negative 5 times n, negative 5 times 2 to get this. Now, the other thing that's true about this is you could also write this as 4n squared minus 5 times n plus 2 because of the distributive property. So the order in which these are written doesn't really matter as far as your products, right? Your products of your factors. But you should leave the terms inside in standard form. Let's take a look at another example. So for this example, again, split your term and then factor out what they have in common. So numerically, the biggest constant that goes into both of these is just a 1, right? X squared is not divisible by 2, so they both have a leading coefficient, or the biggest coefficient that they can be divided by is just a 1. So we're going to pull a 1 out. And then what's the highest degree of x that we can pull out? Well, they both have at least an x squared, so we can take an x squared out. So what do I have to multiply 1 by to get 2? Well, I have to multiply 1 by 2. X squared times what gives me x to the third? Well, that's just going to be an x. Now, in this situation, x squared and x squared, those look the same, right? So you have to think to yourself, what would I have to multiply this by to get itself? Well, what do I have to multiply something by to get itself? That's the multiplicative identity, and that's just 1. If I multiply anything by 1, you get itself. So this is a super common thing that people forget, is when they see that this is the same as what we have, they just generally don't write something. So you need to make sure that you remember to include this 1. Again, pay attention to your sign. It's negative, so we're going to pull a negative out here. And then ask yourself, what do these two have in common? So both 14x and 7 are divisible by 7, so we can pull out a 7. And they don't both have an x, so we can't actually take out an x. So negative 7 is going to be our common factor. Negative 7 times what is negative 14? Well, that's going to be positive 2. And then we also need to multiply an x to get the negative 14x. Negative 7 times what is negative 7? So negative 7, again, times 1 gives us itself. Again, we see these two are the same, so that's our first factor that we're going to deal with. And then our other factor is going to be what we have on the outside. So we have the x squared minus 7. So that would be this second example factored by grouping. So I want you to try and factor this one by grouping on your own first, and then we'll come back together and talk about it. So remember, the first step is split your group and then factor out the GCF. All right, so go ahead and give that a try. Pause the video and give that a try on your own. All right, so now that you've had a chance to try this on your own, let's take a look at what we have here. So these first two terms have a 5 in common. That's the biggest number that goes into both of them. And they both have at least t to the third power. So 5t to the third is going to be our common factor. 5 times 1 gives me 5. And I'm still missing a t, so t cubed times t is going to be t to the 4th. And then 5 times 4 is 20, and then we already have our t's accounted for. Now, in this situation, right, the leading term was positive, so that's why we have this plus here. And then the biggest number that goes into both 6 and 24 is 6. So we're going to take out a 6, and then we're going to multiply that through by t plus 4. Now, they have the same thing here, t plus 4, so that's our first group. And then what's left on the outside, the 5t cubed and the 6, are what make up our second group.